Hi, and thanks for checking in. Welcome to your next online math lesson video. So we've been working with the Pythagorean theorem unit, and up until now we've just been working with the Pythagorean theorem, a squared plus b squared equals c squared, right? All having to do with right triangles. So we have to shift gears today to finish up this unit, and we switch to something that's called the distance formula. Really isn't anything like the Pythagorean theorem, at least not in many ways. So here's your learning target for today, is that you're going to learn to use the distance formula to find the distance between points that are on the coordinate plane. Now the points might be graphed on the coordinate plane, and you might see a line, something such as this. So I'm going to teach you how to calculate the distance between 2 points on the coordinate plane like that. Or you might see simply two ordered pairs like so, where I can teach you to calculate the distance between those 2 points, even though they're not plotted on the coordinate plane. This is really all a formula, as it's indicated here by its name, that it's the distance formula. It's a pretty long-looking formula, but it truly is all calculator work. Once you get the numbers plugged into the formula, which isn't too tricky, it's just a matter of using care and precision, accurately entering information into a calculator so that you hopefully get the right answer out of your calculator. And here is the distance formula. Again, it helps you find the distance between 2 points that are on the coordinate plane. And the formula is written there in red. It says distance equals the square root of, parenthesis, x2 minus x1 squared plus, parenthesis, y2 minus y1 squared. Now there is a lot going on in this formula. I see the big square root, right, that big radical sign. I see that we're squaring a couple things. I see that we're subtracting some values. I see that we're adding some values. So it really does become a matter of order of operations. So I have a nice example here done for you. It says find the distance between these 2 points. And they give you 2 ordered pairs. Point number 1 is right there. There's your x1 and your y1. I highly encourage you to label those. And this is your point number 2, which would be your x2 and your y2. See, once you label x1, y1 and x2, y2, it helps because it makes it easier than when you're looking at your distance formula. It helps because you can look back and figure out which numbers need to go where. So if I'm looking up above still at the formula written above in red, and I'm looking for the x2 minus the x1 values. Well, x2, as I've labeled it, is 4. And the x1 is -2. So it looks like I'm going to have a 4 minus a -2 there. And then the y2 value, if I look down, y2 is 3. And the y1 value is 1. So plugging the numbers in is probably like the hardest part, right? Then it becomes just a matter of all calculator work. So I'm going to scroll down now, and you're going to get to see the work that we did. So just as I did above, I put the 4 right here for the x2 minus the x1, which was -2. And then over here, my y2 was 3 minus my y1, which was 1. And now I just have to do order of operations. You always do what's in parentheses first. 4 minus -2 actually becomes a +6, right? Did you remember that when you subtract a negative, they actually turn into positives? Subtracting a negative is the same as adding a positive. And 3 minus 1 gives me that 2. Next thing you would do in order of operations, after you do what's in parentheses, is you would do exponents. 6 to the second power is 36. 2 to the second power is 4. So I did the exponents. Now what's left? I need to add those numbers, and 36 plus 4 gives me 40. And the very last step is to take the square root. And the square root of 40 is 6.3 once it's been rounded. So see what I mean? You really just got to make sure you're plugging the values in the right positions, and then it just becomes a matter of calculator work. But be very, very careful if you see that you're subtracting a negative, as we were in this problem. We had 4 minus negative 2, which really means 4 plus a positive 2. So be careful of that, and it's going to happen quite often. So here's one. Let's do this one kind of from scratch. We're going to find the distance between these 2 points. I'm always going to tell you to label them x1 and y1, x2 and y2. Now I'm going to write the generic formula here, just so we can see it. It's x2 minus x1, and you got to square that. Added to y2 minus y1, which also has to be squared. Now we're going to plug our numbers in. Big radical sign. x2 is 1 minus x1 is 5, which I'm going to square. y2 is 2 minus y1, which is negative 6. See, I put those parentheses there to kind of separate the subtraction sign from the negative sign. Here I go. 1 minus 5 is negative 4, which I'm going to square. And 2 minus negative 6 really becomes 2 plus positive 6. So that becomes an 8, which I'm going to square. Negative 4 times negative 4 is positive 16. 8 times 8 is 64. Add those together. That gives me the 80. And now I need to take square root of 80. And if I round it, I get an answer of 8.9. So it's not as easy as just counting the boxes. For example, if you were to plot these 2 points, 5, negative 6, and 1, 2, you just plot those on the coordinate plane. You go, oh, I'll just count the boxes between the dots. No, it doesn't work that way. You really can't just count the boxes. A lot of these lines would be on the diagonal, and you can't count the boxes. It's not that simple. So this is an actual formula that helps you calculate the distance between 2 points on a coordinate plane. So if you were to plot these 2 points, they would be 8.9 units away from one another. Maybe this will help you kind of visualize that. Sometimes in these problems, they won't give you the ordered pairs. They'll simply show you a line that has a starting point and an ending point, and they want you to calculate the distance. How far is this point from this point? No, it's not 2. You can't go, oh, from here to here is 1, and from there to there is another, and it must be 2. No, it's not 2. We're gonna actually have to do the math. So here, let's write the ordered pairs. I see this bottom left point is over 1 up 2. That's its ordered pair, or its coordinates. And the point that's up and to the right is over 3 up 4. So it's positive 3, positive 4. Great. Now I have my ordered pairs. It was 1, 2, and it was 3, 4. Now I don't even need that graph anymore. What I'm going to need is room to work. Label them. X1, Y1, X2, Y2. Ready? About ran out of room. It's a long formula. Now, we're going to plug our numbers in. X2 is 4 minus X1, which is 1. Y2. Uh-oh, I wrote the wrong number. Oh, geez, I wrote the wrong number. After I told you to be careful, then I went and made a mistake. Well, I guess that happens. That's supposed to be a 3. That looks better. For this one, Y2 is 4 minus Y1, which is 2. And I'm going to square that. 3 minus 1 is 2. 4 minus 2 is 2. 2 squared is 4, and 2 squared is 4. 4 plus 4 is 8. Last step, square root of 8. 2.8 units. Final answer. See, it's not 2, it's 2.8. You can't just look and try to count the boxes. That does not work. You gotta do the formula. Last one. Same thing. How far from this point to this point, and no, you can't use a ruler, and no, you can't count boxes. All right, let's label our ordered pairs. I see left 2, down 2, and I see left 4, up 3. Left 4, up 3. There are my ordered pairs. That's everything I'm going to need. I'm going to write them. And I'm going to label them. And I'm going to write that big long formula. Phew, my arm's getting tired. Let's plug in our numbers. What's x2? Negative 2 minus x1, negative 4. Square it, add. What's y2? Negative 2. What's y1? Positive 3. Square it. Okay, negative 2 minus negative 4 really becomes negative 2 plus positive 4, which gives me a positive 2. Negative 2 minus 3 gives me a negative 5. 2 squared is 4. Negative 5 squared is positive 25. 4 plus 25 is 29. Square root of 29, 5.4. Final answer, 5.4 units. So it's definitely a new formula. It's definitely a long formula. It's definitely a lot of work, but I wouldn't call it really difficult. I mean, it's really not difficult. You label your points, you plug the values in, and you run through order of operations. And most of it's calculator work. So, I'm sure you already know this, but we'll be working on this concept during the next few class periods. And if you're curious as to what we're going to be doing, here it is. All right? There are some examples where the lines have been graphed for you, and then down below there, 7 through 10, you just see the ordered pairs. So we'll work on this for a day. Here's another side we're going to do. We'll do some of these problems for another day or two. We'll spend a couple days working on the distance formula. All right? This actually is the end of this unit. So as soon as we get through this distance formula, we get some practice with it, a couple days under our belt, we're looking at taking an assessment on the Pythagorean theorem inside 3D figures, and the distance formula. All right? Hey, thanks for checking in, and I'll see you in class. Bye-bye.